Video on how to differentiate log functions. We're specifically dealing with natural log functions here, so we're looking at functions like this, f of x equals log to the base e of x. And just bear in mind that these can be written in a couple of different ways. Instead of using log to the base e, we may see ln, or natural log, being written down instead. If we go to the log tables on page 25, we'll see that the general rule for differentiating a natural log, when it's just the natural log of x, is to just write down 1 over x. But again, just like with the exponential function, I need to be careful here. If I have anything more than x in the log, I'm going to have to differentiate that and multiply it on the end. So just like in the previous video, we can get this rule on page 25 in the log tables, but we must watch out. If the log holds anything more than just x, we must differentiate it and multiply by the derivative. So here's our first example. Y equals ln 3x squared. We want to find dy dx. So first we'll reference the rule from the log tables. And we'll say that whatever our log is of, we'll have to say 1 over that. But I'm not just done yet. I'm going to have to also differentiate this 3x squared because it's not just an x. And I'll multiply the result on the end. In this case, that'll be 6x. And I'll tidy up a little bit to give 6x over 3x squared, which we can cancel down to give 2 over x. Okay, let's look at a second example. So we've got y equals 5 natural log of 3x cubed plus 4 here. And I want to find dy dx. Okay, so first of all, my coefficient out in front here is going to be unaffected, so I'll leave that exactly as it is. And then I know from my rules in the log tables that I want to say 1 over what I have in the brackets here. But I must also then multiply by what I get when I differentiate that 3x cubed plus 4. So in this case, that's 9x squared. I'd like to tidy up a little bit. In this case, what that will involve is just taking what I have at the very beginning, the coefficient of 5, and the 9x squared that I have at the very end, multiplying them together, and they can go on the top of the fraction. And there's my result. Dy dx equals 45x squared over 3x cubed plus 4.